Hi everybody, welcome to a new lecture of ITC 255 where we continue our discussion of probability distributions, introducing the third discrete probability distribution, namely Poisson distribution. Suppose we are interested to study the number of visits to our website per hour. We can use a random variable n to represent the number of visitors to our website in this period of time. Then n can take any value in 0, 1, 2, 3, and so on and so forth. We use Python random variable to study such problems. A random variable n has a Poisson distribution if its PDF or probability mass function or probability distribution function has the following form. F of k in lambda is equal to the probability that n is equal to k is equal to lambda to the power of k e to the power of minus lambda divided by k factorial. With k being the number of occurrences, that means k is either 0, 1, 2, and so on. E is the Euler number, which is 2.718281 and so on. And lambda is the distribution's parameter. With some calculation, we can show that the expectation of n is equal to the variance of n is equal to lambda. Let's consider this example where we use the historical data suggesting that on average 10 visitors per hour visit our website. Using that information, compute the probability that 8 visitors will visit our website in the next hour. We use 8 and 10, which are the inputs in the formula of the Python PDF to get 0.1126. That means the chance that 8 persons visit our website next hour is nearly 12%. Another example, past data suggests that on average 2.5 goals will be scored per game in a FIFA World Cup. Compute the probability that in the next game there will be no goal scored. To that end, we insert the information that we have in the Python PDF to get f of 0 and 2.5, which is 0.082, which is nearly 8%. The next distribution which we consider is uniform discrete distribution. Consider the experiment of tossing a dice. Running this experiment a large number of times results in equal probability of each possible outcomes, namely 1, 2, 3, 4, 5, and 6. Such probability distributions are known as uniform probability distribution. A random variable x is said to be uniform when all of its values are equally likely. That means the probability of x getting or taking any of the possible values is the same. With x taking values in 1, 2, 3 up to n discrete values, the probability that x is equal to x, where small x is any of these values, is 1 over n, with n being the only parameter of the distribution. After some calculation, you can get that the expectation of x is n plus 1 over 2, and the variance of x is n squared minus 1 divided by 12. Consider a random variable which presents the birthday of an individual. Then it has a uniform distribution with n is equal to 365. In other words, each day of the year has an equal chance of being the birthday of this individual with the chance of 1 over 365. Or consider a random variable which represents the area where the spinner will stop has a uniform distribution with n is equal to 4. That means the spinner would stop in any of these 4 areas with 25% chance.